Good morning students. Today we are going to start new chapter 5, that is continuity and differentiability. Actually when we come to the topic differentiation, it becomes very interesting. But the first exercise 5.1, that is based on continuity. As it comes this is theoretical topic. Students, they feel that it is boring, but it is actually interesting. Okay, so continuity, at the word itself make what is continuity, which is continuous. So a function is said to be continuous when we draw its graph without lifting our pen. We can say that a function is continuous if we can draw its graph without lifting our pen. Okay, this is actual basic concept of this one, continuity. It is this, like suppose if I give one example of your function, any function is there fx, and it is given like that x is not equal to 0, it is given 1, and it is given at x equals 0, its value 2. Okay, and you say how we are going to draw it. So we will be saying this rough sketch I am giving you, that is okay. At x equals 0, suppose this is 1, this is 2. Okay, at x equals 0, value is 2, means I will be dark circle I am making it. Okay, and not equal to 0 means any value I am taking positive x or negative x. It is 1, means I am going to take this is 1 and this is 1. But at 0 I will make it hollow circle. This is hollow circle. Okay, this is not this one. Value actually at 0 is what? 2. Okay, and that is what at greater than it is 1, and less than also it is what? Your not equal to 0 means x greater than 0, and with 0 plus h also its value will be 1, and what is 0 minus h also its value 1, but exactly at 0 its value is 2. So if I am going to draw the graph, I am making this, then I need to lift my pen at 0 because value is here. Then again I need to lift my pen, and this. So this is not a continuous function. At x equals 0, it is not equal to. And what we say, actually we say our left hand limit of the function. This is called what? Your left hand limit, which you studied already in this 11th class. Left hand means what? That your limit x tends to 0 minus fx. It is giving me 1. Okay, and right hand limit means you already this also. Right hand limit means what I will say, limit x tends to 0 plus fx, means 0 के थोड़ा सा भी ऐड करेंगे, राइट हैंड साइड पे जाएंगे, थोड़ा प्लस h टेंड्स टू 0, तो वैल्यू इज व्हाट? योर 1. सो आई से व्हाट? दैट लेफ्ट हैंड लिमिट इज इक्वल टू right hand limit, but not equal to function's value at 0, because function's value at 0 is what? Function's value at 0 is 2, so which is not equal to. So this function is not continuous. Not continuous. Okay, similarly one more example I am saying, if it is like that fx is what? That your I will say what? That for x is greater than 0, it is what? Your 2, and x is less than equal to 0, it is your 3. Suppose this is that one. So how I am going to draw the function means y equal to, use parallel to x axis, graph will be there, for greater than 0 means it will be coming at 2. This is 1, this is 2, and so this is okay. Greater than 0, x is greater than 0, it is 2, means I am going to make it this line. Okay, there it is hollow because equal to 0 is not there, so hollow circle will come. Okay, that is greater than 0, function का value क्या है? 2 है. Okay, less than equal to 0, it is what? Your 3, means equal to 0, so it's hollow circle and it will be coming 3. Okay, so what that I need to, when I am drawing my graph, this is continuous, but at x equals 0 I need to pick my pen and I need to come here. Okay, that is okay. So what I say in this one, function's value at 0 is what? Your 3. Function's value at 0 equal to 0 is what? 3. And your right hand limit at 0 means what? That your right hand limit means limit x tends to 0 plus fx, वो क्या है आपका? राइट हैंड लिमिट क्या है? वो भी 3 है. ओके, बट व्हाट इट इज योर लिमिट x tends to 0 minus 0 के लेफ्ट हैंड साइड में, that is what yours right hand limit actually greater than 0, it is 2, sorry, this is 2 right hand limit, but left hand limit is what, that 0 minus 0 के left hand में क्या है 3 है, तो I get what, that your left hand limit is not equal to right hand limit. Okay, left hand limit is not equal to right hand limit, that's why also function is not continuous. Function is not continuous. Got that? Means what I said, to be a continuous function, to be continuous, what three conditions should be? Left hand limit must be equal to right hand limit, must be equal to function's value at that point. All three conditions should be satisfied. Then we say about that function is continuous. So we come to a formal definition of this one. I hope you might have understood this one. What I said, x is greater than 0, मतलब right hand side पे 0 के right hand side पे थोड़ा भी add करेंगे तो it is value 2. Okay, left hand side and equal to 0 it is 3. तो obviously right hand limit is what, 0 plus पे 2 है, लेफ्ट हैंड साइड पे क्या है, ये आपका 3 वैल्यू है, बिकॉज ऑलरेडी गिवन वी रीड फंक्शन लाइक दैट, लेफ्ट हैंड 0 पे 3 है, इक्वल मीन्स फंक्शन की वैल्यू एट 0 ऑल्सो 3. तो वी कैन ऑब्वियसली डायरेक्टली वी कैन रीड द फंक्शन, आई कैन डायरेक्टली टेल what it is giving, right hand limit, left hand limit and function's value I can read from the function this one. Okay, so actually formal definition come what, that a function, a real valued function fx is said to be continuous, at any point C in its domain, okay, x is what here, in its domain, if and only if limit x tends to C fx, function का limit उस point पे must be equal to function's value at that point means at C. Limit exists when, you know, limit exists in 11th we have studied, limit exists when left hand limit equal to right hand limit. So more elaborate way we will say that limit x tends to C minus fx must be equal to limit x tends to C plus fx must be equal to function's value at that point. Means left hand limit of function at that point must be equal to right hand limit and must be equal to function's value at that point. Okay, and all three should exist, then what, function is said to be continuous, So we are going to this one. Okay, some basic if you say this is a particular point and we say when a function is continuous, means when it is continuous everywhere in its domain. A function is continuous. If I say generally a function is continuous, I am not giving you a particular point where it is continuous, means a function is continuous. This implies that function is continuous everywhere. Function is continuous everywhere in its domain. Okay, so for this is very important, function is continuous everywhere in its domain. So what important points are there? Like first is polynomial functions. You need to learn this. Polynomial functions are always continuous functions. Okay, means what, that in any polynomial, suppose I say px, this is your a0 plus a1x plus a2x square plus an xn, this is nth degree polynomial and it is always continuous. You know that is any function, if I say only a0 means it's a constant function, and you know y equal k, a function. If I am going to draw this, a common criteria I am saying this, which kind of graph will come if I say y equal a constant parallel to x-axis. Suppose this is a k distance, I have said k distance, so this is a continuous function. Okay, it's a constant function. Similarly, linear function I can say, suppose identity function I am saying, if I am going to draw the function, this one, linear function means it's what, it will give you this is a continuous function. Similarly, I can say y equal x square, you know what, that it's a quadratic function, quadratic polynomial. Okay, and you know which parabola it is, yours upward parabola. Okay, and if you are going without lifting your pen, this common criteria I am saying, this is through graph, this is also always continuous function. So what, that in this we can say for polynomials, limit x tends to C px is always polynomial's value at that point. Limit x tends to say px equal pc. Means if they are saying that check the continuity of the function, it is given x square plus 7. So I will be saying any point x tends to a. So it will be equal to, I can directly put the value of a here, it will be a square plus 7. Suppose I need to same function, I need to find out the what will be that value of this function. So it will be your limit x tends to 5, x square plus 7. So I will be directly saying what that 5 square plus 7, that is equal to 25 plus 7 means 32. Okay, मतलब वो function क्या particular 5 पे value क्या आएगा 32 if the function is polynomial is given this one. तो limit will be equal to function's value. Limit will be always function's value. Limit of this function will be what here at 5 it will come 5. At 7 it is मतलब 7 के right hand 7 के left hand value will be same. So polynomial functions are always continuous function. Polynomial functions are always continuous function. Similar way we can say rational functions are always continuous. So suppose any function is in the form of yours fx by gx. Okay, this is always continuous function, rational function, provided what gx should not be equal to 0. Rational functions are always continuous. Okay, now same way I am saying third point is yours, your trigonometric functions. Trigonometric functions are always continuous function in their domain. Functions are always continuous functions in their domain. In their domain means what that if you are saying y equals sin x is continuous function in R. Total R means real number minus infinity to positive. Similarly, y equal cos x is also continuous function in its domain, that is your R, real number set of. But if I said y equal tan x will be written how? It is sin x by cos x. It is continuous function because it's a rational function, but cos x should not be equal to 0. Cos x should not be equal to 0 means what is its domain? R minus 2n plus 1 pi by 2. Because odd multiple of pi by 2 cos will become 0. So from real numbers I will be subtracting where cos x will become 0, where n belongs to z integers. Okay, set of integers. Similarly you can say y equal what your sec x. Sec x also same condition will be there, 1 of cos x. This is where the domain will be what your r minus 2n plus 1 pi by 2 because cos should not be equal to 0. Similarly you will say y equal what yours cot x and what cosec x. Also continuous function. Cot x is what is yours cos x by sin x and this cosec x 1 by sin x. They are also continuous function, but sin x should not be equal to 0. Sin x should not be equal to 0. So what that your domain will be r minus n pi, because sin pi multiple of this one integers pi, 2 pi, 3 pi, minus pi, sin will become 0. So from real numbers what I will be subtracting these numbers where sin x become 0, where n belongs to z. Okay. So all trigonometric function are always continuous function. Polynomial functions are continuous function yours. Okay, rational functions are continuous function. Similarly your exponential function are also, exponential function is continuous function. Exponential function is continuous function. Okay, in domain is r. Domain is equal to r means y equal ex, where e value lies from 2 to 3. Okay, e raised to power x. That is also what your continuous function. We will be discussing about this function next video, coming videos. Okay, same logarithm function. Logarithmic functions are also continuous function in its continuous functions in its domain. Okay, domain is what your r positive. It's defined for 0 to infinite, where 0 is not included. So what that if it is your you can say y equal ex, so log of x to the base e we write is equal to y. This implies like that if y equal e raised to power x, so log of x to the base e okay, equal to y. We redid this one, and this is also a continuous function, okay, where x is what, that x belongs to r plus, okay. That is your this one. For continuity, continuous functions are there, okay. Simply how we are going to prove continuity, one simple example I am going to give you for this one, okay. All questions are to be done with the same this yours method, okay. Suppose they are saying you, and see, modulus function is always continuous. Modulus function is always continuous function, always continuous function, okay. How we write it? Y equal mod x. And how I open it? That fx equal, for x is greater than equal to 0, it comes what, x. For x is less than 0, it is minus x, because it opens always positive x. So what, that you are minus x and less than 0. So it will be giving minus, and less than 0 means negative value. Suppose minus 3. So minus of minus 3 will be positive. So y will become always positive. And if you draw the graph of this one, you know how we are going to draw this one. At 0 it is 0, and for positive y equal x, so it comes a straight line, and y equal minus x, but minus of minus value will come always positive, so it will also like that. So this graph is your modulus x graph, okay. That is, and it is always a continuous function. So one example I am saying, in which basic you are going to say, this is your discuss the continuity of the function. It is your mod x plus 3, where x is less than equal to minus 3, and it is minus 2x, where x is greater than minus 3 and less than 3, okay. You need to find out the continuity of this function. So I can more open it easy way. See this one, fx equal, you know, mod x, and x is less than equal to minus 3, means negative. It will open in negative x, minus x plus 3. X is less than equal to minus 3, and it is what, your minus 2x, for what, x is greater than minus 3, less than 3, okay. So you will say less than minus 3, it is continuous function because it's a polynomial, okay. And it is minus 3 to 3, this is continuous function because it is also a polynomial. But at minus 3 I need to check. At which point I need to check? Minus 3. So I will be saying what, that your limit, left hand limit. Left hand limit will be what, your, see this algorithm always you are going to follow. Limit x tends to what, yours, minus 3 fx, okay. Left hand limit what, that yours minus 3 के लेफ्ट हैंड साइड में, तो माइनस 3 माइनस 3 के लेफ्ट हैंड साइड में माइनस. तो आपने क्या बोला, लिमिट x टेंड्स टू माइनस 3 माइनस, फंक्शन कौन सा है, लेस देन माइनस 3 पे फंक्शन है माइनस एक्स प्लस 3. सो आई विल बी राइटिंग माइनस एक्स, ये मेरा फंक्शन है. नाउ आई विल नेक्स्ट स्टेप आई विल बी सेइंग माइनस 3 का लेफ्ट हैंड साइड पे ओके बिट नेगेटिव, थोड़ा सा उसके पीछे जाना है आपको. तो लिमिट यू विल बी सेइंग h टेंड्स टू 0, and instead of my x I will be writing minus 3 minus h, you know, minus 3 minus h, left hand side I need to minus 3 minus h plus 3 I will be writing. Then I will be putting h tends to 0, so it will be coming what there, if your h, this one, this is minus minus plus 3, it will be coming 6. Similarly right hand limit, what you are going to take, limit x tends to minus 3 के right hand side में, तो minus 3 plus right hand side of minus 3 fx. Then I will be putting limit x tends to minus 3 plus. अब माइनस 3 के राइट हैंड साइड में फंक्शन क्या है, माइनस 3 के ग्रेटर देन माइनस 3 पे फंक्शन क्या है, माइनस 2x. तो fx को आप लिखोगे माइनस 2x इज इक्वल टू, अब इसको किस में करेंगे, लिमिट थोड़ा सा h टेंड्स टू 0, माइनस 3 में थोड़ा सा h ऐड कर दो राइट हैंड साइड में, लेफ्ट हैंड साइड में थोड़ा सा h सब्ट्रैक्ट कर दो कि इस पॉइंट के लेफ्ट हैंड में क्या है, इस पॉइंट के राइट हैंड में क्या है. तो व्हाट यू आर गोइंग टू पुट हियर इन माइनस 2, और x की जगह क्या लिखते हैं माइनस 3 प्लस h. Got or not? Now put here h equals 0, तो minus this is 6. So what that your function is continuous, both are giving same, left hand limit is equal to right hand limit, and function's value at minus 3. So you are going to say what, that function's value at minus 3, function equal to minus 3. तो function ये वाला है आपका कौन सा, माइनस एक्स प्लस 3. तो यहाँ पुट कर दो माइनस ऑफ माइनस 3 प्लस 3, तो ये कितना आ गया 3 प्लस 3, ये भी आ गया 6, equal function's value at minus 3, all are 6. So function is continuous everywhere, function is continuous everywhere. So you learnt this one, try to once more go through the theory of this one. One more session we will be taking of this continuity. Thank you students.